So when we're asked to simplify an expression and it has a number and a variable inside a set of parentheses and there's an exponent on the outside, we want to distribute this exponent in. But this 3, it doesn't have an exponent, and it actually has a secret exponent of 1. So what I want to do is I want to multiply the 3 by the 1 and the negative 1. So then I have 3 to the 3rd power and x to the negative 12th power. Then what I want to do is I actually want to figure out what 3 cubed is. 3 cubed is 3 times 3 times 3, which if I type it into the calculator, so if I do 3, and then to get an exponent on the calculator, I go to this upside down V looking thing, I type that, and then I put in the 3 for the exponent, and I hit enter, and it gives me 27. So I have 27 for my real number, or for my number part, and then my exponent is a negative. Negatives means we turned it into a fraction, and we flip the side it's on. So if this was a fraction to begin with, it would have been on the top. It moves to the bottom because it needs to go to the opposite side. And that's my final answer. On number 2, I start off by subtracting my 2 exponents, because whenever I'm dividing variables with the same base with different exponents, I subtract them. Because in reality, I have 7 m's on the top and 4 m's on the bottom. So I cancel out all of the ones that are on the top and the bottom, and I'm left with 3 on the top, so 7 minus 4 is 3. So I have m3 for the first part, and then another m3 at the end. When I'm multiplying 2 m's, or 2 of the same base, I add their exponent, so 3 plus 3 is 6. Number 3 is very similar to number 1. The 4 has a secret exponent of 1. The m has a secret exponent of 1 as well. I distribute my 3 to the exponents. I have negative 4, and I put this in parentheses to the 3rd power. Because the negative belongs with the 4, I want to keep it all together. And then I also have m cubed. Negative 4 to the 3rd power is negative 64. Because my exponent is an odd number, the negative stays. And then I can't do anything with the m cubed. So that stays where it is. Number 4, it gives me a formula. It says v equals pi r squared h. And then it gives me a value that it wants me to plug in. This r equals h over 3. I'm going to plug this in for the r in the formula. So I have v equals pi. Instead of writing r, I'm going to write h over 3, and whenever I plug something into an equation, I put it into parentheses. So this is in parentheses, and now it's squared. And then I have h. What I want to do next is, just like before when these had secret exponents, inside the parentheses in the fraction they have secret exponents of 1, I'm going to distribute those in. So then I have v equals pi h squared over 3 squared times h. What I want to do next is this would have been 3 squared, so I made a mistake. Then what I want to do is I want to figure out what 3 squared is. So I have v equals pi h squared over 9 times h. Because I have 2 of the same variable, I want to simplify it even more by only writing the variable once with 1 exponent. Right now this h has a secret exponent of 1, so I add the 2 and 1 together to get v. So my final answer is v equals pi times h cubed over 9. Number 5 works similarly, but I'm given a different formula to plug into. This volume formula is for a sphere, so kind of like the shape of the Earth. I'm plugging in r equals d divided by 2, and that's going in right there in this formula. So I'm going to start by plugging it in. I have v equals 4/3 pi, and then in parentheses I'm putting in d over 2 cubed. My first step here is to distribute in my exponent. So I get v equals 4/3 pi d cubed over 2 cubed. Next I want to figure out what 2 cubed is. So I have b equals 4/3 pi d cubed over 8, because 2 cubed is 8. Notice, I have 2 fractions here. I have 4/3 and an 8 on the bottom. What I do when I have 2 fractions and all of these are being multiplied together is I multiply straight across. So I have this 4 on top and nothing else to change with it, so I'm going to have 4 pi d cubed on the top. And on the bottom, I multiply 3 times 8. And 3 times 8 is 24. If I take a look at this fraction, I'll notice that 4 and 24 are both divisible by 4. So I'm going to simplify it. It's going to turn into v equals pi d cubed, because 4 divided by... I forgot to say what they had in common. They both have a 4 in common. So if I divide 4 by 4, it just turns into 1, and I don't need to write that out front. 24 divided by 4 is 6, giving me my final answer. When it asks me to evaluate an expression for a given value, what I do is I take the x equals part and I plug it in for my exponent, because the exponent is an x. So I'm going to write f of 4 equals 2/5 3 to the 4th power. So first I need to figure out what 3 to the 4th power is, which it is 81. So then I have 2/5 times 81. Like I said with fractions, the 81 is over a secret 1, so I multiply straight across. That's going to turn into f of 4 equals 2 times 81 is 162 over 5. Same thing with number 7. I'm going to plug in the -2 for the x exponent. So I have f of -2 equals 5 times 4 to the -2 exponent. Remember, negative exponents make it a fraction, so I'm going to start off by rewriting this. I have f of -2 equals 5 over 4 squared. When I move my negative exponent, it turns positive. Then I just finally need to figure out what 4 squared is. And that's 4 times 4, which gives me 16. I did not need to draw one right there. On number 8, it wants me to determine if it's an exponential growth, decay, or neither. Exponential growth is a multiplying pattern. Exponential decay is a dividing pattern, and neither would be things like where I'm adding, subtracting, or just doing a bunch of random stuff between each number. So if I look over here, to go from 36 to 6, I can subtract by 30, or I can also divide by 6. Going from 6 to 1 is still dividing by 6. 1 to 1 6 is also dividing by 6, and 1 6 to 136 is also dividing by 6. So this has a dividing pattern, so this one means this one is an exponential decay. On number 9, when it tells us to pick the exponential model below, this means I have a variable exponent. So I'm looking for things that have exponents that are variables. A has an exponent that's a variable, the t, and that's the only one. C and D are not exponential because they have a number exponent. Because they have a 2 instead of a letter there, it automatically disqualifies them. And then B doesn't even have an exponent at all. Moving on, this one wants us to decide if it's growth or decay, and it wants us to find the rate of change. So if I notice, all my numbers keep getting smaller, and my only 2 choices are growth and decay. So this one is going to be an exponential decay. And then I need to figure out the rate of change. So the way I figure out the rate of change is I take the second number and divide by the first number. I have 67.5 divided by 90. So I'm going to go on to my calculator. 67.5 divided by 90. And it gives me 0.75. The 0.75 is not my answer. Because I know this is decay, I have to subtract the 0.75 from 1. So 1 minus 0.75 gives me 0.25. Because if I have $1 and I subtract 75 cents, I have a quarter left over. And then I need to turn this into a percent, so I move it 2 to the right, the decimal point, and I get 25% as my rate of decay, or rate of change. So my answer is decay of 25%. On number 11, it wants me to find my growth rate. What I do is I take the piece inside the parentheses. Since it's larger than 1, I'm going to do 1.06 minus 1. I need to figure how much is increasing every year. 1.06 minus 1 is just 0.06. And I move the decimal place over 2 to turn it into a percent, and it turns into 6%. On number 12, it tells me it's a decay, and I need to find the percent for this one. So my magic number here is 0.80. I'm going to do 1 minus 0.80, because our growth and decay always come from 1, because the 1 means 100%. If nothing changed, it would be exactly where it's at. 1 minus 0.80 gives me 0.20. Move the decimal over 2, turns into 20% decay. Number 13 wants me to write an equation. It tells me it's going to be C of H for the name. And then it tells me it starts with 250 cells. So I know 250 is the number on the outside of the parentheses. Then it tells me they double every hour. Double means 2. So inside the parentheses, I'm going to put a 2. And then it tells me it happens every H hours. So H is my x. If I take a look, moving on to number 14, it gives me this equation, 25 times 1.6 to the t power, and it wants me to pick which of these is true. Because the inside number inside the parentheses is larger than 1, this means it's growing. If I look at these choices, the one I want is another word that's synonymous for growing, or means the same. Decrease does not mean growing. Increase means growing. So my answer here is B. On number 15, this guy is a scientist and he's making an equation. He comes up with the equation right here. What I want to do here is I'm going to write the equation myself and then see how they're different. Because we know he made a mistake, he just doesn't know where. So I'm going to write down here under the problem, number 4, is this one decay or growth? It says it grows, so I know this is my growth formula. My growth formula is y equals a, parentheses 1 plus r to the t power. So this is the formula I'm using. My a is my initial amount. So he starts with 170 cells. It tells me it grows by 20%, so my rate is as a decimal, so it's going to be 0.20 because I move it 2 to the left. And it tells me that H hours is how we're measuring. So I'm going to plug into this equation. I have B of H, B for bacteria, and then 170, and then in parentheses, I should have 1, because it's an exponential growth, plus 0.20 to the H power. If I simplify, 1 plus 0.20 is just going to be 1.2. So if I compare my function to his function, let me highlight this so it'll be more clear. The difference here is inside the parentheses, he has a 0.2 and I have a 1.2. So his mistake was he forgot to write the 1 in the 1.2. On this one, it tells me that they work at a company and they make more money the longer they work. We need to come up with the equation for how long they work. So just like I did on number 10, I'm going to take my second number and divide by my first number. So I'm going to do 31,500 divided by 30,000. Gives me 1.05. So this is my this is how much it's increasing by it's multiplying by a rate of 1.05. So then to write my equation, I'm going to do S of n equals 30,000, and then in parentheses 1.05. Now, this is the tricky part. My exponent's going to have an n, but because we didn't start at 0, and I need this to whole start at 0, I'm going to do n minus 1. This doesn't make sense to make money even if you're not working at the company. So, this starts when they start working at the company at their first year. That's when they start making the $30,000. Moving on. This one, he's buying a car and it says it depreciates. So we're going to use, for this one, we're going to use the exponential decay equation, which is y equals a times 1 minus r to the t exponent. Decay has a subtract because it gets smaller, and subtraction also makes it smaller. So I read through this problem and it tells me he buys the car for $15,000. That's the initial amount. It depreciates at 20% a year, which is going to be 0.20 as a decimal. And it wants us to write the value of his car in V of t. So I have V of t equals, my initial amount was $15,000. And then I have 1, because it's decay, I use subtract, 0.20 to the t power. Then I want to just do the math on the inside. So 1 minus 0.20 is going to give me 0.80. To the t power. Okay. Number 18 says I'm investing money and I want it to appreciate. Appreciate means go up. So this one works similarly. I'm going to do V of t equals, my initial amount is 30,000 and it's going up 8%, so as a decimal that's 0.08. Start with 3,000 out front. Because it's appreciating, it's exponential growth, I have a plus sign in the middle, and then 0.08 to the t. Then I just want to add 1 to 0.08. So I have V of t equals 3,000 times 1.08 to the t power. Number 19 is very similar to 18, but it has an extra piece in it. So it tells us she starts at $450. It triples, so that's a magic number to mean 3. Every 5 years means that in my exponent, I need to make it so it's in multiples of 5. This one wants me to write it as V of y. Starts at $450. Triples was our magic word, so that goes inside the parentheses. And then my exponent is y, but because it told me it happens every 5 years, I'm going to divide my exponent by 5. And this just makes it so my exponent has to be a multiple of 5. Number 20, it tells us that a company has an annual income over 6 years. It gives us this equation. And then it says it matches the data points that are given. It wants us to figure out how much their annual income would be in the year 2008. It told us that they started in 2001, so the first thing I need to figure out is how many years have passed since 2001. I'm going to do 2008 minus 2001. So if I subtract, it just gives me 7. So now, I'm going to take this 7 and plug it in for the x exponent on this equation. So I have y equals 60,000, and then in parentheses 1.2 to the 7 power. I'm going to type this into the calculator. So what I'm going to do is 60,000, parentheses 1.2. Remember, to get to the exponent, it's this upside down V button, the upside down V looking button right above the divide symbol. And then I do that, and I hit 7, and it tells me 214,990. Because it wants an approximate annual income, I'm not going to include the cents. So this is my answer.